instructional video is over textbook page 182. Two athletes are training over a 2-week period to increase the number of push-ups each can do consecutively. Athlete A can do 16 push-ups to start and increases his total by 2 each day. Athlete B's progress is charted in the table. Compare the initial values for each. What does the initial value mean in this situation? So if we are looking at athlete letter A, his initial value is going to be his starting point, which is 16 push-ups. For athlete B, we're looking at the table, and our initial value is what's paired with 0, and 0 is paired up with 12. And so that means that he can do 12 push-ups. When we're talking about the initial values, we're talking about the starting point. So when they start training, athlete A can do 16 push-ups and athlete B can do 12 push-ups. Equation y equals 4x minus 2, and the table and graph shown at the right describe 3 different linear functions. Which function has the greatest rate of change and which has the least? So for number 1, we have our equation y equals 4x, and so our slope when looking at the equation is the mx piece of the equation. For number 2, which is the table, we have to find our pattern. So 1, 2, 3, 4 is a pattern of 1. 5, 10, 15, and 20 is a pattern of 5. We set it up as a fraction. Y over x, 5 divided by 1 is 5. So our slope for the table is 5. And then for the graph, we're going to pick out 2 points that we can read clearly. I'm going to use the y-intercept 4, and then the point down here at positive 4, negative 4, and connecting my values. Going from positive 4 to negative 4 is a value of 8. Going sideways 2 squares, going from 0 to positive 4 is 4. Setting up the fraction, rise over run, 8 divided by 4 is 2. And because that line is sloping down, it means that we have a negative 2. So for our equation, for number 3, our slope is a negative 2 value. So when looking at the equation, or the question, which one is greatest, we can say that the table has the greatest slope, 5, and the problem with the smallest slope would be the graph, which is negative 2. After school club ate 12 grapes per minute. After 9 minutes, there were 32 grapes remaining. The table shows the number of carrots remaining after different amounts of time. Which snack did the students eat at a faster rate? So if we're talking about grapes, the word problem tells us that they ate 12 grapes per minute. Per is our key word. And then for carrots, we have to solve the table, and we can solve it in pieces. 6 to 8 is 2. Going from 136 to 118 gives us a value of 18. We set up our fraction as y over x. 18 divided by 2 is 9. 9 per minute. You could also solve the second set. 8 to 9 is 1 minute. 118 to 109 is 9 minutes. So that fraction would be 9 divided by 1, which is also 9. And then it goes back to 2 minutes and a value of 18. So again, 18 divided by 2 is 9. 9 carrots per minute. So which snack did the students eat at a faster rate? The students ate more grapes per minute. Burning candle can be modeled by a linear function. So for candle A, we have an initial height of 201 millimeters. So that's going to be our B value, the initial value, the starting height. And its height decreases to 177 millimeters after 4 hours of burning. So if we are decreasing at what rate, that would be a rate of -6. -6 decreasing -6 times 4 hours is -24 millimeters, which when added to the 177 gives us the 201 that we started with. For candle B, we're using the equation, so it would be the -5t for our slope, and then our initial value of the 290. So for our answer choices, it says which of the following statements are true, meaning there could be more than one. The initial height of candle A, 201, is greater than the initial height of candle B, 290. That is not a true statement. The height of candle A decreases at a faster rate, so -6 is decreasing faster than candle B. That is true. Candle B will burn out in 58 hours. So we're going to use the 58 hours to solve the equation. So -5 times the 58 plus the 290 where it started gets us a value of 0. So that's a true statement. After 10 hours, candle A is 110 millimeters. So again, we're going to use that value, -6 times 10. And then we add it to the 201 to get 141. So that is not a true statement. And then candle A will burn out before candle B. So candle B, we know, will burn out in 58 hours like it tells us. If we do the -6 times the 58 hours and we add it to the 201, you end up with a negative value. So A will have already been finished when B